Thank you for attending the webcast Data Science Trends for 2015. I'm happy to introduce our presenters for today, leaders from the Pivotal Data Science team, Annika Jimenez, Kaushik, and Hulya Farinas. Please feel free to submit your questions anytime during the webcast using the chat console. We will do our best to answer them at the end, or if we can't get to them, we'll get back to you via email. Thanks again for being here, and now I'll hand it off to Annika.
Thanks, Catherine, and good morning, everybody, and depending on where you are, perhaps good afternoon or good evening as well. Welcome to this morning's webinar from Pivotal entitled Top Data Science Trends for 2015. My name is Annika Jimenez, and for those of you who don't know me, I'm the Vice President for an organization called Pivotal Data Labs here within Pivotal. And Pivotal Data Labs actually is our internal expert data services team made up of best-in-class data scientists, data architects, and data engineers. We actually thought it would be a really fun way to close out what has actually been a very interesting year of exciting data science project work. And for us to be really clear, that's really high caliber, cutting edge project work in the realm of predictive modeling and machine learning on big data and on Pivotal's distributed MPP or Hadoop technologies. Doing that project work and then at the same time kind of looking towards the new year, really wanting to identify the trends that we believe we're going to be seeing for data science in 2015. I'll explain a little bit more in the next slide why we think we're in a good position as a team to be this presumptuous and kind of assume this role of the predictors of trends for 2015. But before I do that, what I want to do is some introductions. And so today I'm joined by Kaushik and Hulya Farinas. Let's actually allow each of them to start off with with their backgrounds and their role on the team, and then we'll give you a little bit more information on how we've pulled together the trends that we'll talk a little bit about in the session today. So Kaushik, do you want to go ahead and get started?
Thanks, Annika. My name is Kaushik Das. Very happy to be here today talking to all of you. So I head the data science team within Annika's organization for the Americas. And I started, I was thinking as we were waiting for this to begin that actually working with big data a long time ago, before the term big data was well known, as a geophysicist, working with data from seismic surveys, creating images of the underground. And since then, I think I've been very lucky to witness the advent of these new technologies for big data, which has made our work so interesting, and happy to be in the midst of the emergence and the spread of the community of data scientists that we are seeing today.
And then Hulya?
Hi, my name is Hulya Farinas. I'm a master data scientist here at Pivotal Data Labs. I'm also the lead for healthcare and life sciences, retail and logistics verticals, which means that I'm exposed to all kinds of different trends in different verticals.
And then just a quick reminder of my background. I started actually what used to be at Greenplum about over 3 years ago, and had the privilege of beginning to start my collaboration with Kaushik and Hulya, leading the build out of a global data science services capacity for Greenplum and then later Pivotal. And then prior to that, I actually spent a long time at Yahoo, where I led a lot of internal analytic services teams, as well as the build out of big data centered data capabilities globally. So have also had a very interesting kind of career ride in watching the build out of the adoption of big data technologies, not just in digital media, but now, of course, while we've been at Pivotal, across many, many other verticals. So what we wanted to do today, now that you have a better understanding of the role that each of us play and our respective perspectives, kind of the viewpoint that we bring into today's session, is talk a little bit about the methodology that we actually applied in order to come up with these predictions. They're not really cherry-picked necessarily by each of us. We actually decided we wanted to really bring in the viewpoint of the entire team. Thank you, reminder. That team, just as a reminder, is about 30 people. It's a global team, as I've mentioned, with groups in EMEA as well as Asia and Singapore and Australia in particular. And then as well, of course, coverage across the U.S. And this is what we think of as to toot our horn a little bit, one of the best data science teams out there. And we've been doing work, like I alluded to in my original comments, across just about any sector that you can imagine, and exploring many different use cases. So we're really on the front lines of the emergence of our craft and the industry that's being built around it. And that gives us a very kind of luxurious position to really have a sense for really how the overall sector is being built. And in a way, you can think of us as a microcosm or and kind of reflecting and becoming a barometer of the maturity, the analytic maturity of the enterprise class. So for today's session, beyond the predictions themselves, we're not going to make this a big countdown and add drum rolls. I think what we'll do is we'll expose you to our prediction and the trend that we want to highlight. And then you're going to be able to expect just a quick conversation amongst the three of us around that particular trend, where we think it's appropriate, and then we'll move on to the next trend. And we're for sure going to be leaving time at the end of our 10 predictions to hear any questions from you or to hear any specific predictions that you would actually like to pose to this audience that we now have participating in this morning's webinar. So with that, I think we'll move on to the first prediction. You guys ready? Yes.
All right.
So prediction number one, data science in 2015 as a craft will move to the cloud or to many clouds. Thank you. So in particular, obviously you could expect us to make this prediction because we're employed at Pivotal, and at the end of the day, Pivotal is really becoming the embodiment of the convergence between cloud and data. I want to be really clear about what we mean when we say data science will move to the cloud. What we specifically mean is that data science execution, being the ad hoc discovery of insights, building of predictive models, et cetera, is actually going to move to a cloud environment. We're not really referencing the scenario where companies will leverage, for example, BI as a service business models from various startups. We specifically mean companies will be, in essence, leveraging a packaged suite of data science tools and libraries in a cloud, a certified cloud performant capability on a distributed architecture. And they'll do that either on a public cloud or a private cloud. It's not just setting up an account on AWS. It's actually a little bit more involved than that. It's a natural extension, of course, of the build out of data services as a service. We have an eye towards companies like Altascale that are actually extending managed services on top of Hadoop, and we think a very natural next step is to then extend the suite of data science tools and enable much more agile and ad hoc data science execution on top of that infrastructure that is now made available either through the smaller players like Altascale and larger players like AWS, Microsoft, Azure, Google, et cetera. So as a result, as a practitioner, so what does this mean actually for the various stakeholders as a trend in 2015? Obviously, as a practitioner, this is actually almost panacea, right? So for our team, as an example, we would love nothing more than to be able to plug in a much more agile fashion on behalf of our customers, tap into the underlying data lake, secure the right size compute required for the project quickly, drive discovery and the creation of insights in a temporary dev environment, and actually drive the operationalization of those models much more easily than we can right now in a more fixed hardware environment in a private data center. Now, if you're IT, it's also a very attractive proposition because you can actually control your access rights, privacy, security, compliance, while enabling in a much more agile and ad hoc basis access to both data and a broader set of tools to your in-house practitioners. You, in essence, collectively between the two sides, both the practitioners and the and the IT teams, will be reducing time to insights and time to actioning. The overall innovation cycle will be sped up. So it's a really key transition. We believe we're seeing the emergence of this in 2014, but we think it's really going to take off in 2015. Kaushik or Hulya, any thoughts on this one?
And these are the kinds of demands that we see from across different domains, like big pharmaceutical companies with very large R&D departments demand this because there is variation in the compute needs. And also consumer packaged goods companies are desiring this kinds of flexibility and agility.
Yeah. So one of the big attractions for this move is that the expenditure on big data then becomes OPEX instead of CAPEX. And most companies prefer that because then it's a variable cost and you're paying for what you use rather than, depending on some initial estimate.
Right.
Although, there is, of course, some exceptions because some companies prefer to have CAPEX, like in a heavily regulated industry like utilities out here in the United States, because capital expenditure can be written off, they would still prefer to spend the money as CAPEX. But for them also, the cloud is attractive because they are able to regulate how much of that they would use. They're able to turn the tap on and off as they need it.
Yes, yeah, and I think, like we said, it's kind of a natural extension of a lot of the trends that we saw in cloud adoption. It's also going to be the facilitator of really driving data science into the application world, and we'll talk a little bit more about that and some additional predictions to come. And I think with that, we'll move to prediction number 2.
So this prediction is that data science-driven apps will become much more prevalent next year. And this is, almost a natural corollary to data science moving to the cloud. So, as you know, that apps, which are lightweight applications as opposed to heavy enterprise software, are very common now. And even data-driven apps are very common now. So this is the next stage. This is data science-driven apps, where you're not just looking at your data and the summary statistics and descriptive statistics of your data, but you're looking actually at recommendations based on predictive modeling. And this year, we saw a lot of different projects. So this has already emerged this year, and we think that this is going to become really prevalent next year. One big example on the Internet of Things side is GE's Predicts platform. They have already created a platform and have started selling apps and software based on that platform to different players in oil and gas and in the power industry. But the other side of this picture is that the moment you have a lot of different people, especially people out there in the field with their tablets and smartphones accessing the results of models, for example, when they're out there at a turbine trying to diagnose the fault that has happened, it puts a lot of pressure on the architecture, especially the enterprise data architecture. So, I mean, again, data science-driven apps have emerged from Silicon Valley startups, and out here we are very good at building that infrastructure. But as it becomes mainstream, enterprises will need to be very careful about the impact it's having on their architecture. And there we are seeing already advancements like Nathan Mars's Lambda architecture, right, which combines a streaming layer along with a big data layer, which is slower. And we expect a lot of such innovations next year. So it's going to be pretty exciting.
Yeah, so you can imagine, it was one thing in 2014 to prove the value of a data science-driven app. And we were engaged in a lot of projects this year where we were doing, in fact, that. And of course, we were partnering very closely with Pivotal Labs to explore how data science actually folds into the application development process, especially kind of an extreme agile process around app dev. And I think we're very much on kind of the forefront of the ones that are figuring out how to do that well. That said, for an enterprise to actually manage multiple predictive models, both keeping them fresh and up to date with the latest data that's coming in, as well as managing the scoring process, enabling the availability of those scores through APIs, and then the downstream consumption of those scores, the modification of apps in response to those scores. That's a very new kind of cycle of a value chain that the enterprise class is still getting hip to. And I think as a result, everything that Kaushik just summarized in terms of the impact at the architectural level is critical. And we're going to for sure see a very serious focus on that from some of the leading data players across many sectors.
Even if an enterprise is used to building data-driven applications, there's still some new considerations if they would like to make those applications smart, analytics-driven, because then there's this whole issue of where do you keep your models, how often you refresh them, and how do you make those available to your applications, and the additional features, that profiles that you may build. How do you store that? In what frequency you refresh them? So there are a lot of new things for enterprises to think about if they're trying to make their applications smarter.
Right, and APIs, as Annika mentioned, will become very important in this context, and we will see much more widespread use of open standards like PMML, which are critical to sharing of data science models and results.
Right. In essence, this entire prediction and the trends around it really are foreshadowing, I think, even a faster jump to kind of leapfrogging into next-gen data and app architectures. And we've obviously, that's what we do as Pivotal, but we are exactly mimicking, I think, the enterprise readiness to make that leap. Okay, let's move to prediction number 3.
So, as you know, many organizations are facing data science talent shortages. Back in 2011, McKinsey famously predicted that by 2018, in the U.S. alone could face a shortage of up to 200,000 people with deep analytical skills. And a lot of universities like Berkeley, Columbia, North Carolina rose to the occasion and started their advanced degrees in data science. And then there are also some for-profit technology companies, educational technology companies like Coursera, Udacity, that make data science courses available to a very large group of people. But there is still the shortage of deep analytical skills is still very real for a lot of our customers. So naturally, tool vendors responded to this demand, and there's an increased focus on building making machine learning available to practitioners that beyond data scientists. So some of the companies that we can think of, like Alpine, GraphLab, RapidMiner, Paxate, and Trifacta. Some have more holistic approaches, like they worry about data extraction, transformation, model building, scoring in a single environment. Others are addressing only part of the analytics workflow, like data transformation. So building analytics tools for people who do not have a background in data science is not a trivial task. Because if the analyst doesn't have the academic rigor and industry experience, they may not know how to interrogate the data that they're using or the model that they're building, and they can get themselves and the company they work for into big trouble. So that's the danger lurking part. So we predict that the tools will continue maturing, and they will go beyond just estimating coefficients, because we all the data scientists know that that's not very advanced. You need to be able to understand what you're building and then tell a story with it. And we predict that there will be safeguards, so automatic ways to check for assumptions, see if the algorithm that you're using is the best one for the problem that you're studying, understand the shortages, weaknesses, and strengths of the data that you're working with, so that machine learning will be accessible to a larger group, because this is not trivial at all.
So in essence, you're saying to actually embed into the tools themselves, not just an understanding of the predictive accuracy, but measurement of the error and the risk associated with those predictions, so that those can be factored into any sort of actual operationalization or downstream consumption by an app, right? So we love to see the tool space evolve and become more accessible to a broader set of folks. We also get worried when we see some of those tools almost kind of gloss over some of the, again, kind of the rigor that needs to be baked into the capabilities that we're seeing in the tools, and where these tools are being pointed to use cases that aren't just in digital media, for example, but perhaps in other sectors that have a bigger impact on livelihood or whatnot. That becomes much more important.
You just predicted my next prediction.
Don't worry, we still have lots to talk about. Did you have any other comments?
So actually, this reminds me a little bit of when the statistical language was created in AT&T Bell Labs, and R, of course, as you know, the open source language is based on that. So that kind of took modeling on the computer to a much bigger group of people and expanded the modeling community, because now you didn't necessarily have to be good at Fortran, or Pascal to bring back memories to actually write a program. And what we are seeing with tools like these, like Alpine and Trifacta, it's a similar change. You're taking the modeling up one level of abstraction, and with it comes, the added convenience as well as the associated risks.
Okay, well, so that clearly we're alluding to our next prediction. So let's move to that one. Prediction number 4.
So 2050, we predict that 2015 will be the year of data science ethical failures. We're, of course, jumping the gun on our prediction. Because the picture here is a bit obscure. Our friends at Uber got in some trouble for using their data to determine who's having an affair. They call it the walk of shame ride. Recent reporting also suggests that there are misuse of data and data science at that particular company, but by no means they're alone. There more and more companies have ability to collect the data, and now that they have access to technology to sift through these data sources in an efficient way. But as we like to say at Pivotal, with big data power comes big data responsibilities. So there are other important conversations happening, like in August, Attorney General Eric Holder warned that data-driven criminal justice practices could adversely affect certain minority groups, and that new efforts need to be studied further before they are used to sentence a suspect. So all kinds of conversations happening, how to use data, what to study. And some of the ethical failures that we've seen in 2014, of course, will create a backlash, and people will demand knowing where their data goes and how it's being used. In response, we think that companies will start self-regulating and the government can weigh in. And part of that self-regulation, the grassroots movement, the Data Science Association, a nonprofit organization, a professional group, they published a code of conduct that goes beyond just focusing on what you study, but how you present your findings, which Annika was mentioning a little while back. So are we being transparent about what the strengths and weaknesses of the models that we build? Because we do not want model error to be a black box. We want the consumers of data science to understand those strengths and weaknesses. And one of our data scientists, Wu Yang, is actually very passionate about that. And when applications are at the center of enterprises now, it's the way for enterprises to interact with their customers, partners, employees. This is becoming very important. So it's important for data scientists to be transparent about what they built, so that the consumers will not have to believe in it blindly. But it's also a difficult task, of course. It's not very trivial. You just want to be able to explain it simply.
Right.
So that's.
But to be really clear, right? We're actually extending this specifically into the realm of data science, right? Mm-hmm. So we all have played in the data space long enough to know that there's been sensitivities around the use of data, for the last 5 years at least, right? Mm-hmm. I think what we're specifically calling out here is we anticipate 2015, because there's been kind of a broad adoption of data science techniques at the enterprise sector. There's also a kind of an overall immaturity and an understanding of the ethical requirements for the consumption of data science as a function, right? And so to reemphasize Hulya's point, with great data power comes great data responsibility. Right. And even as an example for us, the data science code of conduct that Hulya just mentioned is something that we're looking at very seriously as a potential policy adoption for our team, so that we can actually state with certainty that we will be applying only the most stringent ethical procedures when we're working with our customers' data.
Right, yeah, because, with any usage of big data, you need to be respectful of the rights of individuals. So whether you are, in data science or not, but with data science comes this added complexity that you need to be careful of the assumptions and limitations of your models when you kind of draw conclusions from them and expect people to act upon them.
Okay, I think we've beat that one. Let's move on to prediction number 5.
One which we all feel very passionate about.
Yes, exactly. Prediction number 5.
So this prediction is about that enterprises will shift from Hadoop only to Hadoop++ to meet their data science goals. When I go to customers, I still get asked the question that, so do we need to really roll out Hadoop, or should it be something new like Amazon's Dynamo? And my answer is always that it's all of the above, because what you really need depends on how you're going to use it. And especially, as we mentioned earlier, with the advent of the data science apps, we will increasingly need a data architecture or data lake, if you will, which will have capabilities at different latencies, right? And it is kind of not very useful to think that there will be one technology or tool that will come in and meet all your needs, right? I mean, so for instance, Spark has seen a lot of momentum and is going to actually see a lot of increased adoption that we are seeing in our team as well as out there in the community. And there are other interesting technologies like Tachyon, which can make Spark even faster, coming out of Amp Labs at Berkeley. But what we have seen is that there are certain things which are done well in memory, like real-time applications, and certain things are done better in a relational layer. So we have actually spent a lot of time and effort out here at Pivotal developing and contributing to this open source library called MadLib, which is a set of machine learning tools which work in parallel so that they can work with big data, but in the relational layer. And essentially what we are going to see is that there will be an emergence that as enterprise go to Hadoop, they will actually install Hadoop++. They will realize that with Hadoop, they might need a relational layer like Pivotal's Hawk or Dynamo. And what will emerge is the need, the realization that what people need is a layer for doing data science, which will essentially be what we're calling Hadoop++.
Right, and I think what we see a lot as companies that have gotten caught up in kind of the big data hype, and then therefore the natural extension of that, the Hadoop hype, and we are, of course, one of the purveyors of that hype, so I don't want to deny that fact. However, there's sometimes not an understanding of the true requirements for data science, for machine learning and predictive analytics, and Hadoop's suitability in supporting that as Hadoop alone, as Apache Hadoop, and kind of the MapReduce paradigm that brings. So, as companies are able to move into the Hawk context and leverage existing machine learning libraries like what we have with MadLib, as well as explore further Spark and the new libraries, right, MLlib, et cetera, there will be the build out of an analytic layer that sits on top of Hadoop to specifically meet the data science requirements, not just kind of BI and aggregating data requirements, but the agility and the sophistication and complexity of machine learning and data and predictive modeling. Any other comments on this one? Nope. Okay, let's move on to prediction number 6.
That's my favorite picture. Unlike the One Ring, there is not going to be one algorithm to rule them all. And again, this is similar to the previous prediction where we shouldn't really expect one tool to come and solve all our problems. In the same way, we cannot expect one algorithm to come and solve our problems. In fact, what the way the data science community has developed, we have seen that it has enabled people from pretty eclectic backgrounds, not just the machine learning discipline within computer science departments, but people from mechanical, electrical engineering, econometrics, to join this community, take advantage of our tools, and bring in with them their ideas and their algorithms. So what we are seeing here, though, is that there are a lot of advancements that happen once you bring in your ideas into the realm of data science and big data. For instance, neural networks have been around for a long time, but deep learning has been a remarkably big advancement to that same idea, which we are able to enable in parallel architecture. And we think that it's going to be very promising. It's not going to kill all other algorithms, but it will find increased usage. And Hulya will talk more about that later, some specific usages. But we're also seeing things like bagging and boosting on distributed computing platforms, for instance, as well as graph theory-related approaches to capture context. So although there is no magic bullet, we are seeing a remarkable momentum on working on different algorithms within academia and in the industry.
Yeah, I mean, I think it kind of folds into the earlier sentiment, which is, we're seeing the build out of a rich analytic layer, and we, as the complexity of problem solving kind of broaches new areas and new use cases, and businesses are creatively thinking about how they're going to leverage their curated data. it's going to naturally drive broader the algorithm requirements that come into bear against that, right? And so I think in that sense, we are also very enthusiastic about some of the latest technologies and approaches to problem solving, but we fold them in and leverage them as needed depending on the use case.
And the advancement, and the advancement can come in a brand new algorithm form, or just the way you implement it in a brand new way in a distributed computing platform. So bagging and boosting have been very successful because there are ways for you to turn the problem into a data parallel problem and run many instances of different algorithm flavors, and then just build an ensemble model at the end. And we just see evidence of that, increasing the robustness of the model, getting much more accurate models in using that method. So we see that trend is going to continue in 2015.
And it's great for the data scientists because essentially our toolbox is getting bigger and we are getting more options in terms of tools.
Exactly, yep. Okay, so kind of maybe building even further on that, let's move to prediction number 7. So 2015 will be the beginning of the end of the venture capital-driven proliferation of one algorithm wonders. And then I think for those of you who are children of the 80s, not to actually age myself, you may or may not know the reference that you see here on the slide, which is a scene from the video for Aha's Take on Me, which is probably one of the most well-known one-hit wonders out there, at least for my generation. So I think the point that we want to make here really is, there's a huge amount of enthusiasm and kind of emergent technology build-out that's being financed by the VC communities, by the VCs, and that's very exciting for us as a team of practitioners because we can see firsthand kind of as our craft is maturing. And it goes back to the earlier prediction that we made about the tool evolution. The challenge that presents for the enterprise community is that, in essence, it's fragmenting the market. And it then now is putting the onus on the enterprise to actually sort through that complexity to figure out how they're going to start piecing together the process that they actually have to go through in order to take raw data, explore it, transform it, build features, create models, and then operationalize those models and connect them to apps or embed them into apps. That's an extended set of steps that now has a ton of different tools attached to many different points along that process. So in fact, for those of you who don't know her, Siobhan Zillis works at Bloomberg Beta, has just done a machine intelligence landscape that's quite interesting summary of this fragmentation. It's a good view into just how kind of rich and complex the market is. That said, kind of the downside, as I've mentioned, is that it's putting the onus on the enterprises. It's actually, I think, potentially complicating their maturity around, or their evolution towards increased maturity. I think what we will see is the beginning of consolidation in 2015 and a renewed focus on driving tools down into a common platform or hub that is supporting the analytic process end to end. So just to make this more concrete, obviously attaching some examples, if we're going to use Trifacta for data preparation and then maybe bring in Alpine for machine learning, maybe do some visualization on D3 or even Tableau, and then extend operationalization and leverage figuring out the role of PMML and driving that back into a production environment, or leveraging any one of a slew of vertical-centric one algorithm wonders, as I call them. I think the challenge for the enterprise is understanding really kind of how to deeply embed that as a new capability into the organization rather than just attacking kind of a one-off use case, right? We increasingly are going to want to see the broadening of that analytical layer by bringing together these new capabilities that are currently kind of embodied in fragmented small startups, and we'll see that naturally consolidate in 2015.
Yeah, and the one algorithm wonders, have played their role, right? I mean, they have kind of solved specific problems and sort of spread awareness of data science and the capability of data science, but now it's time, to kind of sort of consolidate those into platform.
Perfect. Okay. Prediction number 8. Got video.
Got video. Probably a very safe prediction. We have, in the last year, we have seen an increase in use cases that feature image and video data. It is evident in the number of blog posts that we have that discusses image processing and video analytics, and of course, being able to implement deep learning in a distributed computing platform also allows the learning of the features and creates brand new opportunities. And a lot of the time, image processing algorithms are implemented in Python and C++, and traditionally images are processed. They're usually underutilized. Whenever they're analyzed, it's a single-threaded processing, and they're analyzed in isolation. It's not usually merged with other structured and unstructured data sources. But we see that in certain domains, especially healthcare and life sciences, security and media domains, there is an increased interest in bringing these unstructured data sources, images and videos, and merging it with other data sources and increasing the understanding of the situation, whatever you might be studying. So our team is working on this for a while now. We have implemented a lot of different algorithms in our environment. So we made image processing scalable, even if the algorithms are very complex and rely on multiple libraries. We have found ways to make that scalable. So we think that in 2015, that demand is going to continue existing, and technology will respond to that demand.
Yeah, and again, it's not necessarily just leveraging the video data by itself. It's kind of drawing upon the same trends that we see underlying big data and data science as a whole, which is actually going back to the stored video files and bringing them together with other sources
Absolutely.
of data that perhaps haven't been brought together before. And now we have the platforms to actually power that, as well as new techniques, including deep learning and others.
Yeah, especially in healthcare, medical images, they are being analyzed, but it is very rare that you'll also marry it with medical history, prior diagnosis, procedures, genomics data, medications, lab results, etc. Just by bringing those data sources together, you have a much more complete understanding of the patient and whatever you're trying to predict, whether it is like comparative effectiveness, whether this cancer therapy is going to be effective for this particular cohort. There is more information. So there's value to extract from images, and we're seeing that companies are realizing this.
Right, and we expect to see it not just in healthcare, but security, Absolutely. Media, et cetera, et cetera. Okay, yep. So we'll move to prediction number 9. So prediction number 9 is 2015 is going to give rise to what we're calling data arbitration solutions, specifically to help address the growing number of proprietary data sets.
Do you want to if I wanted to give an example of that in healthcare, say a fitness tracking device manufacturer may want to create a smart intervention. For that, they would want to have an understanding of the medical history of the user. And that won't be available to them, of course. And similarly, the physicians and providers would want to understand the well-being of the patient in between office visits. So there is value to both organizations to share data, but it is often very difficult, especially in healthcare, to share those proprietary data sources. So a lot of the companies are starting to question that. Is it a prerequisite to have a common data lake so that they'll be able to take advantage of analytics that run off of merged data? There are different methods that we think are going to be prevalent in 2015. One is privacy-preserving data mining techniques instead of just bringing data sources together, have a federation of data sets, and then let the algorithms wander instead of bringing data together. And of course, there are other solutions that will.
Yeah, I mean, I think this was a very common problem in the digital media space. You know, for those of you who are in that world, you know that there are things like third-party data exchanges like that provided by Experian and others that in essence allow for kind of this double-blind anonymization and integration of the data for the mutual benefit perhaps of two parties. I think we expect to see, because of this rise of proprietary data sets as companies have been curating these, and because of the richness of these data sets, especially the potential that they have for actually kind of deep problem solving, maybe across a sector, we're going to see a lot more kind of build out of these third party, both technologies, as Hulya alluded to, as well as services that actually enable the bringing together and the anonymization in a secure environment of data to power data science, but doing that in a security and privacy compliant way.
And we'll actually see new standards emerging as well to facilitate the sharing of data. And some sectors are more ahead of this than others. So in the utility industry, there is a CIM standard, a common information model, where a lot of the data is already being stored in that model. And that process takes a little bit of time because you have to bring many players together, and there are teething problems. But once you get the momentum going, then it's rapidly kind of emerges as a standard, and all software then has to comply with that and actually find it easy to do so.
Yeah, so this is perhaps one that's a little bit more on the fringe and maybe wasn't on people's radar, but we see it. We see in particular these proprietary data sets and the need to leverage them outside of the enterprise becoming an important trend, and we actually think that that opens up opportunities in the market that we'll see exploited in 2015. Okay, and so I think for our last prediction, it's actually a set of predictions.
Right.
I'm going to let Kaushik summarize those as they get into the vertical markets themselves.
Right. So, since our team actually works with companies all across the spectrum of verticals, we see a lot of interesting trends which are vertical specific. And for instance, if you think of the Internet of Things, which actually encompasses many verticals, we are basically going to see two very important things happening next year. One is that the Internet of Things will become smarter, and this will come from applying data science to find value in the data and make it consumable. And particularly, we are seeing the usage of anomaly detection algorithms to predict failures and lead to zero unplanned downtime regimes. And we'll also see more innovation in the algorithmic space in the Internet of Things. But on the other hand, companies are also beginning to understand that they need a strategy to exploit the Internet of Things. So the Internet of Things is going to become mainstream next year. So this November, the Harvard Business Review had an article, for instance, by Michael Porter on how to leverage the Internet of Things. So this has now become like a essential, yeah, definitely mainstream. Internet of Things has become an essential part of the strategy of most big companies and a lot of the medium ones. Now, on the other hand, what we are seeing, the mainstreaming of this will have an effect on different sectors, right? So, for instance, think of connected cars when it comes to automobiles. Think of connected homes. And on the other hand, we are seeing that oil and gas, for instance, has already started have realized the importance of big data and have started leveraging that. And, consumer electronics and utilities are still a little bit behind with a couple of notable exceptions, but they're catching up. And orthogonal to this is the impact of security, right? So as Internet of Things is becoming mainstream, what about the security of that data? So we're seeing a lot of movement and momentum in the security space, where the two big things we're noticing in terms of application of big data to security is a monitoring of lateral movement in networks, and finding anomalies and detecting activities which could be harmful that way. And on the other hand, detecting malware, especially malware beaconing, where you don't even necessarily know the signature of the malware, for which you already have other software in place to detect. So this is kind of a general supervision of your entire network.
And it's really important to mention there that the leadership in that space that's provided by Derek Lynn and then the team that we have here that does a lot of work in the security space. And they're specifically seeing a lot of adoption of, in particular, the problem solving for these two use cases, and also looking at kind of graph-based modeling approaches to solve for in both of these cases.
Yeah, so Derek has innovated and kind of led the frontier of data science kind of into this area. And we are seeing, again, for instance, pharmaceuticals, rapid growth in genomics data sets, which will require pharmaceuticals to actually leave HPC environments for Hadoop as the data grows. In finance, we are seeing increased application of scenario analysis to understand and contribute risk on distributed environments, and also the increasing use of text, particularly in situations like e-compliance. So know your customer or KYC requirements are now legal requirements for most financial institutions, and we are seeing the movement from manually doing compliance, employing hundreds and even thousands of people, to using machine learning. And this will accelerate a lot in the coming year. And then, of course, when it comes to areas like consumer product goods and retail, we are seeing a lot of growth in location-aware apps and the data science to support that. Doing dynamic pricing offline, like Kohl's has experimented with over the last year, and combining online and offline marketing and sales into one unified strategy using data science. And then around that, we're also seeing the importance of data science in product design. So like understanding how people behave both online and offline with products, and incorporating the behavior of the users into design. So that's a lot of different things, but
a roundup of our vertical market predictions. And I think the ones that you just called out really are the ones that we expect to see very strong adoption in 2015, based on kind of the maturity of the various enterprises that are competing in these sectors that we've been working with in 2014 and 2013. It's kind of the natural extension of their maturity and the evolution of their adoption of data science. And so I think with that kind of rounds up our predictions. I think what we wanted to do now is actually kind of move to this hype cycle from Gartner for big data. And I think it's an interesting way for us to wind down our set of predictions for 2015, knowing that this actually, I think, was published in August of 2014. And again, it's kind of Gartner's view into the various, sub-components of the big data space and where they sit on their hype cycle, including, of course, those that are nearing the dreaded trough of disillusionment. I think it was interesting, and we're not, to be really clear, we're not necessarily highlighting this hype cycle because we agree with it 100%. In fact, there's a bunch of elements of this particular hype cycle that we actually found ourselves disagreeing with a fair amount, and maybe it's worthwhile commenting on a few of those things as well. And then as we do that, we'll share a few of our thoughts, and then shortly after this, we'll have a few more minutes left for questions, so stay with us if you'd like to participate in that. So returning to this visual, I think the thing that struck us at the outset was kind of the placement in particular of the Internet of Things at the peak of inflated expectations. And that's one of the areas that I actually would disagree with. Now, I think they're signaling that there's kind of a longer term evolution for this particular item, 5 to 10 years before it moves into this plateau of productivity. I do think that that's true. I think that we're just at the beginning of kind of adoption of the Internet of Things and kind of the understanding of the enterprise class of how to actually leverage the Internet of Things.
Right.
And I don't know, if I had to disagree just generally, I think we're not so sure that there will be a trough of disillusionment for the Internet of Things. I mean, there's a lot of lessons already established just generally around weblogs and how weblogs could be consumed, as well as other sources of data. There's a lot of pre-existing knowledge that players who have the opportunity to leverage the Internet of Things can kind of actually base their strategies on. So I think we're a little bit more optimistic, and we would also put it a little bit earlier in the curve as well.
Right, yeah, and the bottleneck there is not really the technology, it's kind of getting the data together from different players, and we have seen a lot of movement towards solving that problem this year. So we think that it is definitely on an upswing.
Yeah, great. And then I think the same goes for, let's see here, some of the other, we would agree with kind of placing earlier in the curve the as-a-service offerings, data as a service, and some of the others. I think to our own number one prediction with data science moving to the cloud, we're just beginning to see that emerge as the natural next step for the industry, but we do expect that to get big traction in 2015. And then I don't know, Hulya, if there was an item in here that you wanted to pull up.
I wanted to pull out the supply chain big data analytics one, because in the 90s, a lot of enterprises spend a lot of money on building supply chain management solutions, and many consider that sold. There are a few who are realizing that there's an increased amount of data now, much more granular, that will allow them to make better business decisions. So it's not necessarily solving brand new problems, but increased data availability makes these problems new and requires brand new approaches. And I think the placement of it sounds about right. I don't think the news have gotten to everyone yet.
Yeah, right. Yeah, and I think the way to take this is, if you think about all of our predictions, in essence, we're signaling that there is a maturing in the understanding of how to leverage big data technologies and to apply them to the business needs based on the data that is available to that company. And bringing distributed compute capabilities into their architecture, which incorporates a lot of different open source technologies, proprietary technologies, et cetera, and understanding how to architect that into the platforms and then apply it to problem solving across many different verticals and use cases is kind of where we are in the overall process. And so we expect 2015 to be the one where, there's true traction on that on multiple points of the stack. And I think in a way that, that's kind of what you're seeing in this hype cycle as well. So I think, I don't know if we have any other comments on this. It's a kind of a good way to summarize, what some of the folks who are paid to opine on big data are thinking about big data. You now know our predictions from Pivotal, reflecting the footprint that we have globally across many different sectors. And I think with that, we want to take a couple minutes and take some questions, and I'm going to bring that back to Catherine and see if she has any she would like to pose that may have come up from the audience during the presentation.
Great. Thanks, Annika. So one of the questions that came in initially was that you haven't talked about the role of optimization in the data science process. Any thoughts on its role in 2015?
Oh, that's an excellent question. My background is in operations research, and I do believe optimization being the last mile of predictive analytics. So once you understand the causalities, how do you act, you can inform the decision maker, be a decision support system, but there are also many instances where you would want to feed that into an optimization routine and have all kinds of capabilities on our technology stack to make that happen. We do believe in the marriage of machine learning and optimization, and we see an adoption of that in 2015.
Any other questions?
So another one came in. It says, common threads through all of these predictions are 1, anomaly discovery, 2, behavioral modeling, and 3, personalization. Can you comment on that?
Yeah, sure. So that's actually a very good question because a lot of data science kind of does boil down to those approaches, but they are by no means exhaustive because, for instance, there is the whole area of demand modeling in general, right, which enables us to understand all the factors that affect demand and therefore predict both at a strategic and tactical level how our actions can influence the outcome in different scenarios, right? So there is that. So there are a few other things there, like, for instance, we spend a lot of time, especially when it comes to the Internet of Things, in understanding time series data and dealing with time series data and understanding the patterns there. And sometimes that, again, leads to anomaly detection, but in other times it just leads to a greater understanding of the levers that affect a particular system of machines.
Yeah, and I think we are seeing, again, as part of this kind of natural maturation at the enterprise level, there is a consistent theme, which is, especially when you think about the concept of all of this being powered by a data lake, there is this consistent theme that we're seeing of companies building a 360-degree view of X thing or event that matters to them. That could be a patient, the quantified patient. It could be a consumer. It could be a product. We're seeing that in the CPG sector where they're building that profile of the life cycle of a product, inclusive of even the manufacturing line. I think that is raising kind of the natural problem-solving questions that can be asked once that 360-degree view of the product is getting assembled. And I think we're at the point now where there's just a natural, because that build-out has happened, there's just a natural phase to exploit what can be asked of all of that data that we're seeing now in 2015.
And anomaly detection especially is probably part of any lab engagement we have anyways. Like when you have, a lot of companies believe that if their data is messy, there's no value to get. And we don't believe that at all, because there are all kinds of sophisticated methods that you can use to identify what is true, what's not, cross-validate the data, detect anomalies, and then imputation methods so that you can improve the data completeness so that it will be ready for data science. So it is almost a prerequisite to any lab engagement, and we've been educating our customers about the value of it, and we see the increased appreciation of such methods.
Great. Great question.
Great.
Any other ones?
So maybe one more, if you guys are able. I know we're a little over time here. What are the skills which are going to be in demand in 2015 from a data science perspective?
So when we hire data scientists, and we have built up a good team here, we look at skills in essentially three axes. The first one, of course, is having a very good understanding at the algorithmic level of the math that's needed to solve problems of data science. And the base is, of course, statistics and machine learning, but then people have often specific expertise in different areas. The second thing is a domain knowledge, which is coming from the side of the business. The use cases that are formulated after which you effectively apply data science require an understanding of what goes on in the domain, and that is the non-mathematical aspect of data science. So we really value expertise in those areas in different domains. And there is, of course, along with the math on the first axis, of course, is knowledge of technology. And here we're looking more for people who are capable of learning technology very quickly, with specific, a lot of comfort with programming and rapidly picking up new technologies, because as you are well aware, the specific tools that will become popular and important tomorrow are not here yet.
And so I don't know that it's different. Do we think that the profile of folks that we will be looking for in 2015 is different from the one that we've used in hiring up until now? I don't think so.
No, I don't think so.
I mean, there's going to be a specific drill down into some of these new techniques, but we're hiring the kind of people who come in ready to dive into those. We're not specifically going out and trying to find, for example, somebody out of AI who is going to help us open up a new area. I think we've applied a pretty consistent profile, programming, stats, domain knowledge, and we've been pretty successful.
But once the tools become so mature that you don't really need a lot of programming skills, maybe the storytelling part of the equation.
Yes. So that's the last part, which is very important, is the storytelling part, is that because you remember that we are not operating in a vacuum as data scientists. Our results need to be used by people, consumers, public, or employees of an organization, and we need to be able to build a narrative and explain what we have done, rather than just give some results out of a black box.
Yes, I agree with that. I also think that signals other roles outside of just the data scientists that become also increasingly important. People that we used to call engagement managers, whose job it was to actually engage with the business and help them consume the output of the analytic process.
Right.
I think it goes on both sides, but I think we're still seeing the build out organizationally of kind of the community around data and data science. We'll continue to see that mature into 2015 as well. So Catherine, I think that might do it for us. Perhaps we respond separately to any questions that we didn't get to.
Yeah, we'll send the question list to you guys, and you can respond via email to the folks that we weren't able to get to. I guess we'll bring this to a close. We'll be sending out the links to this webcast recording and a slide share deck of the session within the next few days. And there's also lots more information on the Pivotal website if you're interested. So thank you all again for joining us, and have a great day.